السلام عليكم ورحمة الله، ازيكم عاملين ايه؟ ان شاء الله النهاردة هنعمل كويك ريفيجن على حاجات كده معينة احنا اخدناها السنة اللي فاتت وهنحتاجها ان شاء الله السنة دي، وياريت نركز بس شوية. تمام. اول حاجة هنتكلم عليها الاتوم. What is meant by atom? The atom is the smallest part of matter. It consists of two parts, nucleus and electrons. The atom consists of nucleus and electrons. The nucleus has two particles inside. It has positively charged particles called protons and neutral charged particles called neutrons. They have no charge. They are electrically neutrons. So, inside the nucleus, we have positively charged particles called protons and electrically neutral particles called neutrons. The second part of the atom is electrons. What are electrons? They are negatively charged particles that revolve around the nucleus in energy levels. As we see in the picture, here in the center we have the nucleus, which contain two types of particles, as we said, protons and neutrons. And around the nucleus we can see the electrons rotating around the nucleus in energy levels. Okay, so the atom contains nucleus and electrons. For any element, for any element we must know two things, the atomic number and the mass number. The atomic number and the mass number are written in the left side of any element, as we can see. Here, aluminium, it has two numbers written in the left side of it, 13 and 27. And sodium, it has also two numbers, 11 and 23. This number is called atomic number. This number here is called atomic number, the smallest number. And the biggest number is called mass number. What's meant by atomic number? It's the number of positive protons inside the nucleus or the negative electrons around the nucleus. So, atomic number is the number of positively charged protons inside the nucleus, and it's equal to the number of electrons around the nucleus. What about mass number? The mass number is the sum of the numbers of protons and neutrons inside the nucleus. As we said before, the nucleus has two types of particles, protons and the neutrons, and the summation of their numbers equal the mass number. The mass number is the biggest number, but the atomic number is the smallest number. Here in this example, we will see how can we get the atomic number and the mass number, number of protons, number of electrons, and the number of neutrons. To get the atomic number, we will look at the symbol of the element. Here, aluminium, it has 13 and 27. The smallest number represents, yes, the atomic number. So, the atomic number equals 13. What about the mass number? It's the largest number, as we can see, 27, so the mass number equals 27. To get the number of protons, it is equal to the atomic number, and it's equal to the number of electrons. So the number of protons equal the number of electrons equal the atomic number, which is 13. What about the number of neutrons? To get the number of neutrons, we subtract 27 minus 13. To get the number of neutrons, we do this, mass number minus atomic number. We have two numbers, the largest minus the smallest, to get the number of neutrons. Here, the number of neutrons equal 27 minus 13 equal 14. In this table, we can see many examples. Number 1, hydrogen. Hydrogen has 1 and 1. The atomic number is 1. The mass number is 1. The number of protons equal the atomic number equal the number of electrons equal 1. What about the number of neutrons? Atomic number and the mass number. We have two numbers. 1 minus 1 equal 0. Hydrogen doesn't have any neutrons inside its nucleus. Number 2, calcium, 20, 40. The atomic number equal 20. The mass number equal 40. What about the number of electrons? It's equal to the number of protons and the atomic number, so it equals 20. What about the number of neutrons? 40 minus 20 equal 20. Example number 3, carbon, 6, 12. the atomic number 6, the mass number 12, the number of electrons equal 6, the number of proton equal 6. What about the number of neutrons? We subtract 12 minus 6 equal 6. Example number 4, we have chlorine. Chlorine 1735. The atomic number equal 17, the mass number equal 35, the number of electrons equal the number of protons equal the atomic number equal 17. What about the number of neutrons? 35 minus 17 equal 18 neutrons. Example number 5, sodium Na1123. The atomic number equal 11. It's equal to the number of electrons and the number of protons equal 11. The mass number equal 23 and the number of neutrons equal 23 minus 11 equal 12. Then we will talk about electronic configuration. What's meant by electronic configuration? We have electrons around the nucleus revolving in energy levels. The energy levels are imaginary roots. We can't see them. Okay? In these imaginary roots, which are called energy level, the electrons rotate around the nucleus. In the heaviest atom, we have only 7 energy levels, which are called K, L, M, N, O, P, and Q. Again, we have 7 energy levels rotating around the nucleus in the heaviest atom. They are known as K, L, M, N, O, P, and Q. Okay? To distribute the number of electrons in this energy level, we do the following. Here in this example, we have helium 2 and 4. What is the number of electrons? The number of electrons equal the atomic number equal to. To do electronic configuration, we draw the nucleus at the circle, and then we put the number of protons and the number of neutrons inside. Here we have 2 protons and 2 neutrons. Okay, to distribute the number of electrons in the energy level, we do this. First, we draw the first energy level, which is called K. We have how many electrons? 2. The first energy level K, take the 2 electrons. Let's see the next example. Lithium 37. We will draw the nucleus at the circle again, and we put the number of protons and the number of neutrons inside. Then we draw the first energy level K. The K energy level only take 2. It doesn't take more than 2 electrons. Okay? So how many electrons do we have left? We have 3. Here we put 2. So we have 1 electron left. The 1 electron, we will put it in the second energy level L. The second energy level takes the 1 electron left. Here in example number 3, we have sodium atom. The sodium atom 1123. First, we draw the nucleus at the circle and we put the number of protons and the number of neutrons inside. We do electronic configuration by distributing the number of electrons in the main energy levels. First, we draw the first energy level K and we put 2 electrons in it. It doesn't take more than 2 electrons. It's saturated by only 2 electrons. Then we draw the second energy level L. The second energy level is saturated by 8 electrons only. It doesn't take more than 8 electrons. Okay? So how many electrons do we have here? 2 plus 8 equal 10. But how many electrons do we have in the sodium atom? We have 11 electrons. So we have 1 electron left. We will draw the third energy level M and we will put the last electron in it. So we get this electronic configuration K2, L8, and M1. In the second example, we see argon 8 and 40. It's an inert gas, okay? First, we draw the nucleus at the circle and we put the number of protons and the number of neutrons inside. We start by drawing the first energy level K, which takes only 2 electrons, okay? It doesn't take more than 2 electrons. Then we draw the second energy level L. It's saturated by 8 electrons and doesn't take any electrons more. So here we have 10 electrons, but in argon atom we have 18 electrons. We start by drawing the third energy level M and we put the 8 electrons left in it, okay? And by this, I think we remember the electronic configuration and the atomic number and the mass number of any element.